So, yeah, my name is Tim Dewhirst. I work for KDAB based in the UK. I'm going to be covering a bit more of what Sami had covered in the Qt and Cloud Services talk earlier on. So if you were here for that, we'll probably be covering some similar topics, or rather related topics, but not directly dealing with just cloud services or backend as a service, but general web services and their use. And it's my experience, our experience from development over the last couple of years, the kind of issues that we've seen, the kind of things that we've been asked to do by clients. So there's one problem, right, straight up with web services. It's seriously, there are acronyms all over the place. So just don't worry about that. I'll try and cover as many of the acronyms just in case you don't know what they are, but it is acronym central. They're all over the place. You can't miss them. Very roughly, we'll talk a little bit about what web services are, a very small section on the history of web services, what I consider to be the most popular service types at the moment, and then obviously, this is a Qt Developer Day, where Qt fits into this, both from a client side and also a server side. So client side is probably the most common case that we'll cover, but the server side is also interesting and something that I think not many people have really considered up until now. So one thing, I have a bit of a cold. Can everyone hear me at the back okay? It's all right at the back? You can hear me? Yeah, someone's nodding. No one's shaking their head. It's good. The increasing the volume is just me speaking louder, right? So I'll just speak louder in that case. That's fine. Okay, so the W3C, the World Wide Web Consortium, they say a web service is a software system designed to support interoperable machine-to-machine interaction over a network. So far, so boring, right? It doesn't really mean anything. It's just a method of communication between two electronic devices over the web. That's the important part, right? So it's going to be over the web. Normally, it's client-server. Actually, doesn't always have to be the case, but normally it's client-server, and for discussion, we'll call that a web service, okay? Web services are obviously standing on the shoulders of giants. They're all built on existing web technologies. They're usually quite simple. So this is one of the great things in their favor. They're extremely widely available, and more often than not, the data, the payload, is human readable. And this can be very, very useful, especially if you happen to be developing a client application for a client who gives you some specs that aren't really correct. And so you develop something according to their specification and it doesn't work. So then you have to try and figure out why it doesn't work, because the person who wrote the specs has usually left or moved on or something like that. So what's wrong with old school RPC methods? I don't know how many of you are familiar with things like Corba or DCOM or ICE or so on and so forth, or even your own custom protocols. What's wrong with those? Well, actually, in many cases, there's a lot right with them. I mean, if you need very low latency, or you're transferring unusual data, or it's binary data, then sometimes this will be a better fit. But specifically today, I want to talk really about web services and why it's interesting, why you should be interested in them. The first point of contact really for web services that most people will come across is mobile applications. Of course, many smartphones these days have the ability to go and browse websites, arbitrary websites. That's no problem at all. But the reason why people normally want to use a web service or invest the effort in creating a web service is because they want to create a special mobile application which will improve the user experience. We all know that browsing an arbitrary website on a smartphone isn't the best thing ever, right? I mean, it's usually not correctly formatted for mobile devices. If it is, it's usually cut down or it's missing some features. And so, you know, this is one of the primary motivations. You get a much better user experience. Obviously, web services can be used in other ways. You can have a website that is used and you take parts from other services, create a mashup, and then hopefully the sum on your website is greater than the parts. Hopefully. Sometimes it's not. Sometimes it's complete Web 2.0 junk, but that does happen. Web services are also a huge informational resource, whether you're interfacing to a mapping service or things like Amazon Web Services. Their e-commerce service contains all kinds of information about, well, obviously the things that you can buy through Amazon, but it's got a huge amount of metadata about all of these things that you can buy. And you are free to query that if you want to. So if you want to add, album art lookup to your music application or something like that, and you don't want to pay money for it, then actually a good place to go looking is probably on Amazon, right? Because they have all of this music that they sell, and they'll always have the artwork associated with it, as well as other related information, other things you might like, some information about the artist and so on. The same goes for services like Last.fm. You can query about a particular artist or an album. It will give you back something interesting that you can then use in your application. Interfacing to web services is definitely becoming increasingly important. This is something that we've seen over the last 3, 4, 5 years. More and more people don't want just an application to be developed. They want an application to be developed that interfaces with something else. Right? So whether it's their web service or someone else's web service, they want something that is larger than the application that you're developing. So a very, very quick bit of history. Fortunately, the history doesn't go that far back for web services, only as far as 98. The very first web services were very, very simple. WDDX, I doubt anyone has come across this here. It's the Web Distributed Data Exchange. It was basically a huge pile of XML that was transport independent. So it could be transferred by raw sockets or an SCP or FTP or HTTP or anything, basically. XML-RPC built onto the top of that, combining both individual method calls and data in a reasonably structured format. Then from XML-RPC, we moved on to SOAP, which was touched upon by Sami earlier on, and that's actually still a reasonably popular web service. It was much more popular 5+ years ago. It's still there, and I'll touch upon it again in a minute. And then shortly after that, we have REST, and this is really, in my opinion, the principal mode for most web services these days. So let's moving forward a little bit more. Then we have JSON RPC. So I'm assuming that most people are familiar with JSON. Obviously, if you're used to using QML, then you're using it already. But again, I'll touch upon that in a minute, just in case there's anything that's not particularly clear. So the three most popular service types at the moment really are SOAP, JSON RPC, and some kind of a RESTful web services interface. So I'll quickly discuss those. We'll have a look at the differences between some of them, and then we'll have some examples. So starting with SOAP. Originally, it stood for Simple Object Access Protocol. It's an evolution of XML-RPC. And does anyone know who Don Box is? No? No? So he was one of the original designers of COM. And if you're familiar with COM and the level of engineering that's involved in COM and some of the interfaces that are exposed across COM, you might have a bit of a hint about what SOAP looks like, right? In general, it's HTTP and XML. WSDL, anyone know what WSDL is? No, maybe. So it's a web services description language. It's basically a huge chunk of XML, which contains a specification for the data, the methods, the endpoints, transport, and so on. It's very verbose. I mean, really, there's a lot of stuff in there. And I guess you probably don't believe me. So just to illustrate the point, I'll show you the WSDL file for a simple SOAP test service that's available. All it does is it's got a single method that you can call. You pass it a string that indicates the city that you're interested in, and it will return to you some information about the weather in the city. Right, that's it. So single function call, one server, returns some information about the weather in the city. So can anyone read this? Right. That's just to define the service. right? That's it. So it's pretty complicated already. Actually, pretty complicated doesn't really touch it. Once you start to get into more complicated services and you have more complex data types and you have data types that support inheritance, for example, then your WSDL file gets really complicated and your SOAP client also gets really complicated. Never mind. Right, okay. I'm still not convinced, to be honest. We do, I mean, KDAB do make an offering for SOAP support, both for the client side and the server side. We have KD SOAP. And basically the pattern is you get the WSDL file, you generate code from the WSDL file, and you compile that, and then you can use that within your application. And that can be either for a client or for a server. Okay, so the upside is that you have a well-defined interface. You get a schema that describes the data types. You get a schema that describes the function calls. That's great. And people do use these tools to generate the WSDL files or to generate the stub code that will create or consume the SOAP calls. But it is tricky. The last time I tried to use the Python SOAP library, which is supposed to create automatically a proxy for from the WSDL file, pretty much nothing worked, and it was very, very difficult to debug. It is really genuinely verbose. There's a lot of data there. If you want to consider transferring binary data, large amounts of binary data, then there are some extensions to these, but it's not clear how well supported they are. So people usually have some kind of workaround. So, okay, that's one possibility. So you got SOAP. Oh, hey. So then we can consider something like JSON-RPC. So just in case anyone isn't familiar with JSON, it's JavaScript object notation. Very, very straightforward. You basically have an object type, an array type. You have some primitive types, number, string, bool, null. It's very, very easy to parse, and it's obviously human readable, and it's reasonably compact, right? So, but if you're used to developing QML or doing any kind of JavaScript development, then you're probably already quite familiar with JSON. Because what you can do is if you get a chunk of JSON, you can literally eval it, and it will become an instance of an object. Objects in JavaScript are described by, well, the object notation. That's why it's called what it's called. In case anyone has missed JavaScript in the last few years, this is pretty much what it looks like, right? So we have a map, a series of keys. You can obviously nest maps within that as well. You can have arrays, numbers, booleans. Again, it's very, very simple to construct. It's very easy to parse. It's human readable. It's reasonably compact. If you ever did have a problem with the size of the data being too verbose, you can obviously compress it as well. JSON-RPC, what else can we say about that? Well, it's very lightweight. It should be stateless. It's transport independent, and in fact, more often than not, you'll see it transported just across raw sockets, but you can also transport it across HTTP if you want. It can be inter-process, it can be same process. It's very flexible, it's very easy, it's very lightweight. It is quite popular, especially in embedded circles. Okay. So moving on to REST. Again, this isn't also not a particularly new idea. This is REST stands for representational state transfer. I told you it was full of acronyms. They're all over the place. So RESTful constraints. They're basically a series of constraints for a system to be considered RESTful. It should be client-server. It should be stateless. The data should be cacheable. It's probably going to be a layered system. So there is no absolute requirement on the endpoint. It lends itself well to a system where you have load balancing in place, whether that's by round robin or whatever technique you want to use. There is one bit that no one ever implements, which is the code on demand. That's entirely optional. The idea is you should be, or the server should be able to deliver to you a chunk of code that will modify the behavior. I've never seen that implemented, which is probably why someone at the spec committee decided that it should be optional, because someone clearly wrote it in and then thought, actually, no one's doing this, so that becomes optional. And it should have a uniform interface. So what do I mean by that? The main idea with REST is that we're reusing the existing vocabulary rather than extending it. So REST uses the standard HTTP verbs. So get, post, put, delete. Whereas, for example, something like XML-RPC or SOAP extends the vocabulary. It adds new methods. And these can be completely arbitrary. And REST is really based around the idea of resources. So again, that seems perhaps a bit arbitrary. So what we've got here is, hopefully everyone can see this. On the left-hand column, we've got a couple of URLs. So one is from the imaginatively titled server foo.com, and we have images. So this is a collection resource. So if you were to do a get on that URL, then what it should return to you is all of the images in that set. If you do a post, it creates a new resource in the set. If you do a put, it replaces everything in the set. And if you do a delete, it would remove everything in the set, right? So you've got something describing what the resource is, and then you've got a series of verbs that operate on that resource. You can extend that, and you can have an element resource. So if we've got an ID for an image, image number 1, then a get will obviously get image number 1. A put will replace image number 1. Delete will delete image number 1. And a post in this context doesn't really make much sense. So you don't have to implement all of the verbs. That's fine. But hopefully you get the idea. We have a concept of collections, items. If this wasn't images, if this was another kind of arbitrary hierarchy, a post would probably then contain another collection which you could add elements to. But in this context, in this example with images, it doesn't really make much sense. Types of data. It's obviously very, very resource dependent. What you'll get back is a MIME type that tells you what the data is. So following on from the example, foo.com images 1 is going to return to you an image ping or JPEG or something like that. It can be XML, it can be JSON, it can be HTML, it can be raw text, it can be pretty much whatever you want. But there'll be an accompanying MIME type that will tell you something interesting about the information so that hopefully you have a chance to do something useful with it. So REST JSON. This is probably the most popular type of web service at the moment, in my opinion. It's a RESTful service, so it adheres to all of the constraints that we previously talked about, but the data that comes back, or if you're submitting a post, the data will be in the form of JSON. You can obviously eval this in your JavaScript context, so it's designed to work obviously not just with clients written in C++ or Lisp or C# or whatever, but also from other web front ends or websites too. So there is a slight extension that it's worth mentioning, especially if you're going to be developing a client that's interfacing with a web service. There is something called JSON-P. The P stands for packaged. The idea is that you have this concept of a same origin policy. So normally if you have a website, then if you do something in JavaScript, you're normally not allowed to access something from a different website. So it has to come from the same server. There is one way to get around this, and that is to effectively wrap everything in a function call, which is then directly executed, because script element is exempt from this same origin policy. So the return JSON will just be whatever the function is that was supplied, the function being called, and then the interesting blob of JSON passed, which will then be evaled into an object that's passed to the function. That's pretty much all there is to it. You will normally have to supply the function that you actually want to be called on return, but there's not much else apart from that, so don't worry about the JSON-P. Whoever's listening to the recording probably just heard me cough very loudly. That's all the microphone is for. It's for recording. So probably time for an example. There is a company in Edinburgh called Blip Photo. It's a social photography website. They have a RESTful JSON API, and the idea is that you can, view images, upload your own images, write a small blog about the photograph you're taking. You can rate images, you can leave comments, all that kind of stuff. You can subscribe to other users, you can manage your subscriptions, and so on. They have a pretty comprehensive and reasonably sane web services API for creating your own custom client or taking the data and putting it on your own website or whatever. So at this point, I'll hopefully just show you roughly what the application looks like. Oh, Apple's decided that I need some new software. Okay, so this was originally written for to run on a Symbian device, so it's QML and Qt. It just shows you a collection of photos. You can sort of flick through them. It will go and download the latest images as you do so. So these are all random images of random things from random people. If you click on one, it should, there you go. It'll show you something about the photograph. It comes from a particular person. Apparently this photo is not interesting enough to have any comments on it. And you can obviously choose other things about it. So you can choose different users or whatever. So we might come back to this later on. Okay. Hang on. Right. So, using Qt to access a web service. One of the interesting things about the talk earlier on about Qt and cloud services from Sami was that he was really approaching this from the QML side. And a lot of the development that we've done over the last couple of years has been from the sort of traditional C++ and Qt side. So slightly different approaches. But as was mentioned during the talk, Qt obviously has the right kind of tools to support this development, right? So you obviously have Qt Network Access Manager, no problem. If the data is being returned to you as XML, then you have the DOM classes, even though apparently I heard from someone that they're being deprecated. There's also the streams classes too. And for JSON, in Qt4, if you're working in Qt4, then there's an open source project called QJSON, which will allow you to map to and from qvariants. We also have our own code that does exactly the same. I think probably it's been reinvented a couple of times. And in Qt5, it's obviously built in. So you can go to and from JSON and qvariant. We're done, right? So that's all there is to it. We don't really have anything else to do. Well, unfortunately not. In my experience of developing clients for web services, the most difficult thing over the last couple of years has definitely been dealing with authentication. There are a couple of flavors that are predominant, XAUTH, OAUTH, and there are some bits that it also helps to understand if you want to get into this as well. And again, I think this was mentioned in the cloud talk, HMAC. Encryption too, if you want to encrypt the data that's being transferred, then, well, fortunately in this case, it's pretty much all done using HTTPS. So there isn't a huge problem there. You just have to be aware of it and make sure you handle your SSL errors if there are any, and then everything should be good. So, authentication. In the early days, it used to be pretty much home-rolled, and we still come across some web services where the authentication is home-rolled. This is by and large dying out, mainly because the home-rolled schemes that we see are not particularly good, and no one gets it quite right, and there's all kinds of problems with it. So then OAuth. This is, hands up, anyone familiar with OAuth already? No, yes, some people, you must be, surely, right? It's been around for a while, 2006, it's just been updated. It's getting worse. So, what is OAuth? So the idea is it's a method of granting access to resources, REST resources, right, to a client that is not the resource owner. So in this case, the client means the client application. For example, allowing a photo printing application to access your images that are stored online at another service. So you can have one application accessing your photographs, and you have to give it permission to do that. But you don't want to give your credentials for your storage to this other application because you've got no idea what they're going to do, right? So you want to have a system where your credentials are yours. You can come up with a scheme to allow this other application to access your data on your say-so, but not to actually give it your credentials. You want to keep your credentials safe. So the one thing that you need to understand when you're starting out with OAUTH is, okay, first of all, it's absolutely possible. There's no problem implementing it, but it's fiddly. It's really fiddly. You really need to read what you get from the client very closely. It's usually not going to be following the spec exactly, and the spec has got enough wiggle room that there can definitely be some changes here and there. They can tailor it to their own needs, and there are some options as well. The kind of tools you need, SHA-1, and there was a mention of SHA-256, which I'll confess I didn't realize was in Qt5 by default. We tend to use an implementation that we wrote. So you can do this with Qt4. If anyone is interested in the SHA-256 code, just let me know. You need HMAC, which is, well, I'll cover that in the next slide. You usually need some other hashes like MD5, something like that. This next word is really designed to be pronounced as N-once, and not nonce, which is a number that's designed to be used only once. Only once. And yeah, SHA-1, MD5 already in Qt, and in Qt5 it sounds as though you're going to have SHA-256 as well. So good, that's all good. We're getting closer. So what is HMAC? It's a hash-based message authentication code, and it's actually pretty easy. And if you just take this block of code and you apply the appropriate hash, then what it does is it allows you to create a hash that verifies not only the integrity of the message, but who sent it to. Because what you do is you supply a secret, a common shared secret that you know and has been given to you, and then you also pass in your message too. So this allows you to create another new hash that allows you to verify that the message that's being passed is correct, but also that the person on the other end is who they say they are. So that should be good to go. You can take that if you want to. N-once, there are a number of ways of generating this, but again, it's usually pretty simple. This one just creates a byte array containing the current date time in milliseconds or time t, ands on a random number, generates an MD5 hash from it, chops off the ends, returns that. It's fine. Make sure everything is initialized properly. So you probably want to seed your random function, especially if you're on Linux, which I don't know if this is fixed in Qt5, but certainly in Qt4 the rand function wasn't particularly good. And then QUID, if anyone's ever had any problems with that on Linux, it's because the rand function isn't particularly good either. So it is fiddly, right? There are definitely a few steps that you have to go through. You have to usually register your client with the web services. And that was touched upon in the cloud talk. What you do is you sign up, you get some kind of a secret that then goes into your application. You use the secret and your ID to get a temporary token. You're then usually redirected to a verification site. You put in your credentials for the service that you want this other application to access. There's a callback URL that's called. That usually then also contains some useful information. That information is then used to go and get a full second set of tokens, and then you can actually access the service once you've got the full tokens. Right? So this is the kind of rough pattern that you have to follow, and most of them will follow this. XAUTH, I haven't seen this in many places, but just in case you happen to be implementing it. For example, Twitter used to support this, similar to OAuth, but the idea is it avoids the need for this validation callback URL. You pass in a username and password, and it's typically only for sort of official applications. So you may come across that. Again, read the documentation very, very closely. It'll help. Another big thing to point out is every web service that I've come across so far is different, really. The web services themselves, the actual functions that are called and the kind of data that's being passed around isn't radically different, but the way the authentication is done is usually quite different. So, for example, we worked with a streaming audio service recently, and they wanted everything time-boxed. So you had to go and fetch a time from the server. You then had to get the token within a certain amount of time. The time was very prominent in the API. Definitely read the supplied documentation closely. If all else fails, and it definitely has failed in the past for us, either the technical knowledge doesn't exist on the other end or whatever, then you need to break out Wireshark. Has anyone used this? Yeah, good. So this is really great. I mean, it will basically trap all of the traffic going across the network. And for example, if you happen to be contracted to do a migration of an iOS application to BB10 or something, it's quite likely to happen, then quite often the only way to figure out what is actually going on with the web service is to poke the application on iOS, trap all of the packets going past, and have a look at what's going on. It's obviously very popular. Facebook, Twitter. Some APIs are better than other. The Twitter API is actually reasonably sane. It's only the authentication that is particularly tricky for Twitter. The Facebook API is easier to authenticate against, but it's not brilliant. It's not terrible, but it's not brilliant. Sometimes you find that you have a library, a native client library that will help you support a particular web service, and certainly that's the case for Facebook and Twitter if you happen to be running on Android or iOS. If you're on anything else, you're a bit stuck. So you usually have to do it yourself. Okay, so we'll have a quick look at some code for both BlipPhoto and for Twitter, just so you get an idea of what goes on. So this is just lifted directly from the code, right? So this is the process of actually signing in. BlipPhoto is a bit unusual. It's more like XAUTH than OAuth. You actually pass it, because this is a semi-official application, you actually pass it a username and a password. So we do actually have to get the timestamp though. They're one of these web services that insists that we check in and get the time from their server. So get timestamp in this case actually calls our server, asks what the time is. We store that. That's important. We create our n-once. We concatenate some stuff together. The n-once plus a timestamp plus our shared secret. We MD5 hash that. Then we make a list of parameters that we want to add on to the request. So we need to tell it about the API key, the format, blah, 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 password, email, n-once, timestamp, signature. You join all of those together. You go and do a get. And then in this case, we've got a helper function that allows us to make a blocking RPC request. If it times out and nothing comes back, then you failed. If there's a problem with the username and password, you'll get an error returned. We'll then take that variant map. I mean, this wraps up a lot of stuff, right? So the make blocking RPC request wraps up listening for the request to be finished, any errors from the request actually being finished, getting the return data, parsing it from JSON, turning it into a QVariant, and giving it back to you. But it allows the code to be a bit more easily understood. So that's actually reasonably straightforward, right? I mean, there isn't that much to it. The only unusual thing is that you really have to check in with the time and pass the username and the password. Not too difficult so far, right? So Twitter. Well, this is a bit more of a classic OAuth scenario. We start the authentication. We obviously check if we're authenticated already. Again, we build up the parameters. There's a callback that needs to be passed. That's one of the things that will be called with some information when we've been through the authentication step. There's our key, that's a shared secret. There's the n-once. There's the signature method that we're using. So with OAUTH, you've got a choice, but you can see it's a SHA-1 that we're using here. We also need to get a timestamp, but in this case, it's not the server timestamp, it's our local timestamp. We need to tell it which version we're using, so 1.0. We create a request, get all of these arguments. We also pass in another secret. Again, this is something that you'll find if you're dealing with OAUTH. You really, really need to keep track of which tokens you have, which secrets you're supposed to be using, because sometimes you have multiple secrets, multiple tokens, and it can all get a bit confusing. And then we post that and we listen for a reply. So it's probably worth having a look at what create request actually does. So create request creates the signature-based string. So we pass in the method, whether it's a post or whatever, the RI arguments. Those are the default arguments. So 15 minutes. And if there's any additional payload, we have to create a signature from that. So we pass in super secret token, the thing that we're signing. That becomes the OAuth signature. We then put this information for Twitter into the header. So that's where it goes. We join everything together, make a very, very long string in the header, and then send that as well as the authorization header. That's pretty normal. And then the other interesting thing to look at probably is the create signature base and the create signature method. So what that does then is, and this is also quite common, I think Amazon Web Services do this too, is when you're passing in a whole pile of parameters, you need to make sure that all of the keys are sorted lexicographically. You put them all together, then you encode them. You have to make sure you don't percent encode things twice. That's another very, very common pitfall. And then return that. And in this case, you can see that what we're doing is we're then taking all of that, ordered parameters, everything percent encoded. We're concatenating a consumer secret and a token secret. And then we're using that as the key to make an HMAC using SHA-1 with the data, base64 encode it. Job done, right? It's already like 20 steps just to get through the authentication. And this is absolutely the bit that always catches you out. It seems like a lot of hassle. So I guess the next thing is, well, that was from the client side. Server side. Creating or interfacing to web services from a client point of view is something that, I mean, it's just a matter of fact, right? Someone will ask you to create an interface to a web service, but turn it around, you might want to create your own web service in Qt. Okay, why? So standards, that's the number one thing. If you want to deliver something to your client that is going to be well understood by lots of people, and you have lots of flexibility in how it's going to be used, and it avoids lock-in, then a web service is probably a pretty good starting point. Going back to one of the very first slides, if you have a case where you know you need minimal latency, or it's very, very high data throughput, or it's something a bit special, then fine. You can choose a different RPC system. But I propose that actually a regular web service is it's a pretty sensible way to expose something as a callable interface. Okay, so how do we go about creating a web service in Qt? Well, one of the really great things that I'm sure absolutely everyone knows about in Qt is that it has some great introspection capabilities. So you can use the meta object system to tell you a huge amount about your QObject subclasses, right? Has anyone come across QInvocable? Yes, no, maybe, possibly, right. So what you can do is you can mark particular methods as invocable. Once your QObject subclass, as long as it's got the Q_object macro at the top, has passed through mock, you will have some meta information about it, including a list of all of the methods, including you can distinguish between private and public slots and things that are invocable. This allows you to invoke methods by name, right? So this is great. We already have the tools to go to and from JSON invariants. So we also know from QMeta method what the types of the parameters are, so this is good. We have QNetwork Access Manager, we have QTCP Server. So then the idea is that you take a QObject subclass and make it a callable thing. I already had the card that showed me I have 50 minutes, so I don't, in fact I've got 10 minutes. So I don't have enough time to show you exactly what this code looks like, but if anyone would be interested in seeing what the code looks like for a JSON RPC server that works in exactly this way, come by our stand afterwards and I'll talk to you. So then the question is, what's the scope of this, right? I think realistically it's for embedded devices. If you come by our stand, you'll also see another demonstration that's been mocked up. It's got a tablet that talks to a Raspberry Pi for home automation. That's the kind of thing that you probably want to have a small, simple web interface running on. Embedded devices. It's clearly not for the next Amazon, right? So we're not even thinking about considering supporting hundreds of thousands of users or scaling or, round robin type services or anything like that. Just, forget it. So authentication, that's the big thing. Given the scope, if you want to create your own web service, it's unlikely that you actually need to go ahead and implement OAUTH or XAUTH. But it's obviously not beyond the realms of possibility, and it is well specified, and it's obviously doable in Qt. You also have SSL for encryption. You could just stick with basic authentication as well. You could just pass a username and password. It's entirely down to scope. I mean, if this is something that's going to be deployed to millions of users and it's security sensitive, then that's something you have to take into consideration. If it's a very niche product that's only going to be used within your home, the chances are basic authentication and some level of encryption is going to be okay. But that's entirely up to you. Okay, conclusion. Web services are very, very, very widespread. I mean, they're all over the place. The chances are you've got a smartphone that's got some kind of application on it that interfaces with one, if not multiple web services. It's simple, right? It's using existing technology. It uses a human-readable format normally. It's easy to parse. It's easy to work with. There's good support for it already in Qt. Okay, it's fiddly. Fine, it is fiddly. But as long as you get reasonable specifications from the person who's actually creating the web service, then you should be okay. It gives you some flexibility. The other thing that I didn't touch upon was if you create your own web service, it means that, especially if you have a RESTful JSON type interface, it means that if someone wants to create a user interface to your application using HTML5 or something like that, then they can, right? So they have that choice. You're giving the client extra. It's possible to give them, expose to them a QObject subclass that is a callable thing that they could create a user interface for in HTML5. And that's basically it. So thank you very much. The next slide has got some references on it. Right. So interesting stuff here, and yeah, that's it. Thanks.
So questions now.
Hi.
Just out of curiosity, have you looked at the stuff that QtDD12 does? There's like a QHD.
Yes. Yeah. And they had support for especially XML-RPC. The majority of the libraries that use Qt to access web services are client only. That's the first thing that we found. And sorry. Okay, I'm not entirely up to date on it. It's absolutely possible they added server support as well. The last time I looked, I think it was just XML-RPC as well, which isn't quite as popular anymore. So yes, I mean there are libraries available, but by and large, I didn't find all of the building blocks that we tend to use, HMAC and so on, and they seem to be kind of a bit limited in scope. So there's definitely more scope for more of this stuff to go into Qt as, you know, an add-on library or something like that, because it's my impression that the number of web services that people are going to be accessing is only going to increase.